That should be a review, right? Trinomial means there are three terms. A term is separated by plus or minus. So here's our first term, second term, and third term. So if you can see that whatever that first letter is, it's a number squared or a quantity squared, and whatever your last term is a perfect square, then if you can take that term and multiply them together by 2, you should be able to just call the factor pairs of a squared plus 2ab plus b squared a plus b quantity squared. Okay, the only difference here, this minus sign in front of the 2, if that's a minus, and then it's a positive if it's a plus between the a and the b. Notice that the third term is always added, right? Because if you were to factor this out, even if it was a negative b, right? Whatever b is, we don't know what it is, but we know it's a negative b. So negative b times negative b is always going to be a positive b squared. So this is always positive. This is positive if a plus b squared. This is negative if it's a minus b squared. Okay. And yeah, if I just keep reiterating, I know if this doesn't make sense to you, I wouldn't worry about it. Okay. Basically the first term and the last term are both unnumbered squared. Spencer, I can write a note to myself, so no. One second. No, you do not. Okay. I just want to make sure. Okay. First term and the last term are both perfect squares. Okay. That means if this is 9, the square root of 9 is 3, right? That's a perfect square. The middle term is either 2 times a and b or negative 2 times a and b, right? We saw this back in 5.4 when we practiced multiplying polynomials. Now we're going to go backwards with them, okay? When you look at your trinomial, you're determining, is this a perfect square? And is this a perfect square? If these are not perfect squares, you're not going to use this, okay? If these are both perfect squares, then look at your middle term. Is your middle term 2 times this term times this term, but not squared, right? We'll practice this, don't worry. Okay, for example, I'm going to say x squared plus 10x plus 25. Okay. Oh, sorry, you couldn't even see that. I didn't put it low enough. Is this a perfect square trinomial? Are these perfect squares? And I know that I'm saying this doesn't, you can do this without knowing if they're perfect squares and without using this, but it is valuable to know what I mean when I say a perfect square. So a perfect square means I can take something and divide it, like take the square root of it, right? So x times x is x squared. So x squared is a perfect square. This color is not showing up bright enough. 2 times 2 is 4. So 4 is a perfect square. 3 times 3 is 9. So 9 is a perfect square. You can basically just use a calculator or even Google perfect squares ? And they'll list all the perfect squares because you're just going whole number at a time and multiplying it by itself or squaring it, right? So x squared is a perfect square because it is x times x, right? 25 is actually a perfect square because it's 5 times 5. Good. So we have found that since this is plus, I'm going to call it this, okay? So I see x squared plus 10x plus 25. Is it the same as a squared plus 2 times a times b plus b squared, right? If so, that means a is x, right? Because x squared is a squared, so a is just x. B is 5 because the square root of 25 is 5, right? So if I put that in, that means I have x squared plus 2, a I said was x, b I said was 5. So this is all we're doing. And then b is 5. X squared plus 2 times 5 is 10 times x plus 25. Okay, so I see that's a perfect square. That's a perfect square. This happens to be 2 times that a times that b. Okay. This factors as, so that means it does follow this rule. So it factors as a plus b squared. And we already decided that a is x, b is 5. So it's x plus 5 squared. Okay. Another example might be y squared plus 6y minus, nope, it has to be minus, sorry, plus 9. That was the whole point, is that's always plus. So if I looked at this and I said, are these perfect squares? Y squared, that means a is going to be just y, and b is going to be the square root of 9, which is 3, right? So does that mean I have a squared plus 2ab plus b squared here? That means I would have y squared plus 2 times y times 3 plus 3 squared, which is 9, right? Y squared plus 6y plus 9. Yes, right? So that means it is a plus b squared. Again, you are welcome to use the traditional method. You'll still be able to factor it. Okay. Perfect square trinomial. Sorry, I didn't give you an example with the minus sign. I had already written that plus, so it was too late. Example 1. We have x squared plus 12x plus 36, not 3. Remember, our two models are a squared plus 2ab plus b squared equals quantity a plus b squared. And the only difference is this minus sign. So this one's minus 2ab and it's going to be minus b. That's the only difference, okay? This is still a, this is still a squared, this is still plus b squared. So those are our two formulas that we're using. X squared plus 12x plus 36. So is this a perfect square? X squared is a perfect square because x squared is x times x. 36 is a perfect square if you want to go backwards. So we can say 6 times 6 is 36, or we can say the square root of 36 is 6. Okay. So according to this, x squared, the square root is x, 36, the square root of 36 is 6. So that means my a is x, my b is 6. And now we're going to test and see if a squared plus 2ab plus b squared will give us x squared plus 12x plus 36. So we said that was x. That was x. That was 6. And then that's 6 squared. X squared plus 2 times 6 is 12 plus 36. So that is true. So that means I can factor it to a plus b squared. A is x, b is 6, not b squared. Alternately, right, we can do a plus ax squared plus bx plus c the old way, the way we've been practicing previously. In that case, a is 1, b is a positive 12, and c is 36. So now we just multiply to equal 36. add to equal 12, and we think, what are the factors of 36? We have 1 and 36. We have 2 and 18. We have 3 and 12. And you can just keep going. 4 and 9. And then obviously 6 and 6, right? And then you think, what adds to 12? This becomes 37. This becomes 20. This becomes 15. This becomes 13. And this becomes 12, right? So I know that my two factors are 6 and 6. So that is also the factor pairs x plus 6, x plus 6, which I can simplify to x plus 6 squared because it's itself twice. Okay, so if you don't want to do it this way, you can still do it the way we've been doing it in previous lectures. Good. All right, back to the a to a b, right? Can I take the square root of 16x squared? The square root of 16 is 4. The square root of x squared is x. So the square root of 16x squared is just 4x. But the square root of y, there is no perfect square. Okay. I don't think I meant to do this. I think I meant to write that as a 1. But basically the first and last terms are not perfect squares. And this is a letter. So I'm just going to scrap this. Sorry, guys. I need to fix that in future lessons. Ignore that guy. We do have it down here with a y squared. It might work there, yeah. All right, 25x squared plus 50x plus 9. So again, right here, we said the square root of 16x squared is 4x. We can do that again here. The square root of 25x squared, the square root of 25 is 5. The square root of x squared is x, right? The square root of 9, our b, is 3. So that means I know my a and my b. A is 5x, b is 3. Any questions? So just like the square root of x squared was x, the square root of 36 is 6. The square root of 25x squared is 5x. The square root of 9 is 3. So my a is 5x, my b is 3. There's a plus sign in front of the 50x. So we're going to say it's a squared plus 2ab plus b squared. And if you're faster at this, you're welcome to skip like checking that it makes sure. If you know that 5 times 3 times 2 is going to be 50, that's okay. All right. So a squared becomes 5x squared, right? And we have to put parentheses because there's a 5 and an x. If I don't put parentheses, then it's just regular 5 with an x squared, but it's actually going to be 5 squared times x squared, okay? Plus 2 times a, which was 5x, times b, which was 3. 2 times 5 times 3. Good. Plus b squared, and b was 3. So that's 3 squared. 2 times 5x times 3, you can take the 2, the 5, and the 3. You get 30. X plus 9. So what we see here is that it does not give us a squared plus 2ab plus b squared. Those are perfect squares, but the middle should be 30x if this was going to be a perfect square trinomial, okay? If this doesn't work, you have to go back to this method. Sorry, not fun, I know. So which is 25x squared plus 50x plus 9 A is 25, B is 50, C is 9. And you can always check and make sure you can't divide anything out, right? There are no common denominators. So we're going to multiply to equal A times C and add to equal B. So we're going to add to equal 50, multiply to equal 25 times 9 is 225. Good. All right. Don't worry. 225 is not super bad. 225 is 1 and 225, which is not going to add to 50. You can't divide it by 2. You can divide it by 3, right? 225 divided by 3 is 75. You can divide it by 5, we know, right? And get, oh, sorry, 225 divided by 5 and get 45. Ooh, that looks good, right? 5 and 45 will add to 50. So I know it's not fun with the big numbers, but just think about what you need to add or subtract to equal, and you can kind of ignore the really off ones, right? But 5 and 45 multiply to equal 225, add to equal 50. So we have 5x squared, or sorry, 25x squared plus 50x plus 9 becomes, remember we leave the 25x squared, we leave the 9, and then the middle term of 50x becomes 5x and 45x. Good. And then we just factor by grouping. 25x squared plus 5x. 25 and 5, you can divide them both by 5. X squared and x, you can divide them both by x. So that becomes 5x times 5x plus 1, right? If I divide that out. Here we have a plus 45x plus 9. That's a plus, so this is going to be a positive number. 45 and 9, you can divide them both by 9. 45 divided by 9 is 5. X divided by nothing is still the x. 9 divided by 9 is 1. So that's 5x plus 1 times 5x plus 9 as our final answer, because it was not a set of, it was not a perfect square trinomial. Good. All right, here we go with this one again. So we know that the square root of 16x squared is 4x. The square root of, much better, y squared is y. Good. So that means my a is 4x and my b is y. This is a minus, so we're going to be looking at this one. A squared minus 2ab plus b squared. Let's fill in with what we have. So we have 4x, remember to keep it in parentheses, squared minus 2 times 4x times y plus y squared. That one's not in parentheses because it's only one term. So it doesn't really matter if it's in parentheses or not. Here we have to distribute that squared. So 4 squared is 16 x squared. 2 times 4 is 8. Y squared is just y squared. So it looks like a squared minus 2ab plus b squared is 16x squared minus 8xy plus y squared. Good. That means we can use a minus b quantity squared. So we know this becomes a was 4x minus y is b is y squared. Good. Good. Okay. Next one is called the difference of two squares. Difference is the name of it. That is the difference. Difference means subtract, okay? The difference of two squares, so just like we talked about the perfect squares, You can just list them: 4, 9, 16, 25, 36. Okay. This is going to be a perfect square and this is going to be a perfect square. So you can say a squared minus b squared is equal to the quantity a plus b times the quantity a minus b. Okay. All they're saying is the difference of two squares factors into the sum, means add, and difference of the items being squared. Okay. Notice that a squared minus b squared is not the same as a minus b squared. Those are different things. Okay. So what we're dealing with right now is a squared minus b squared equals quantity a plus b times a minus b. I'm going to write that same thing on the top of this page. Case. The difference of two perfect squares factors to the sum and difference of the two items being squared. Okay. X squared minus 9. What is A and what is B? A is X because the square root of X squared is X. B is 3 because the square root of 9 is 3. Remember that this is always minus. So we're not saying negative 9. We're just saying 9. The minus is part of the formula. Okay. A is X, B is 3. That means X squared minus 9 will always factor to X plus 3 times X minus 3. Okay. Next, here, A is the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. B is the square root of 1, not negative 1, right? The square root of 1 is actually just 1. So A is 2x, B is 1. That means 4x squared minus 1 becomes 2 plus 1 times, 2x plus 1 times 2x minus 1. Okay. Here's a tricky one. Can a fraction be a perfect square? So you're seeing, this one's a little simple, right? The most challenging part is deciding whether this is a perfect square and this is a perfect square. Yes, 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 yes. A fraction is a perfect square if both the numerator and the denominator are perfect squares. So the square root of 16 over 25 is the square root of 16 over the square root of 25. If I can square root both of those independently, I get 4/5. So the square root of 16/25 is 4/5. So as long as I can take the perfect square of the top and the bottom of the fraction, that's a perfect square as a fraction. A is the square root of y squared, which is y. B is the square root of 16/25, which we decided was the square root of 16 is 4. The square root of 25 is 5. So B is 4/5. All I have to do is say A plus B times A minus B. Y plus 4/5 times Y minus 4/5. It doesn't matter if you put the minus in front either. You can say that this is X minus 3 times quantity X plus 3. The order does not matter. All right. 36a squared minus 49b squared. Again, it's helpful to just Google perfect squares. The perfect square, or sorry, the square root of 2 is 4. The square root of 3 is 9. The square root of 4 is 16. The square root of 5 is 25. 6 is 36. 7 is 49. Good. So even though this looks odd, we know that the square root of 36a squared is, square root of 36 is 6. A squared, the square root of a squared is a. the square root of 49b squared. I did not leave myself enough room. A is the square root of 36a squared, which is 6a. B is the square root of 49b squared, which is 7b. So that means we have 6a minus 7b times, I just keep writing sixes. All right, 6a minus 7b times 6a plus 7b. Another thing to think about, sometimes you can factor out a common factor. Here, for example, 36 divided by 3 is 12. 49 divided by 3 is not. You can always check though, okay? 4x cubed minus 49x, you can factor out an x. 4x cubed minus 49x, I can take out an x. 4x cubed divided by x becomes 4x squared. 49x divided by x is 49. Okay, because x cubed is not a perfect square, right? That's a perfect cube. That we cannot use in this formula. Now we have x on the outside. I guess I have to rewrite it now. 4x squared minus 49. That was for no reason. Don't worry about it. We have x on the outside. A is the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. B is the square root of 49. Ignore the negative. The square root of 49 is 7. Good. So that means I have 2x minus 7 times 2x plus 7 with an x being multiplied by all of it. X times the quantity 2x minus 7 times the quantity 2x plus 7. If you want to check your answer, you can go back and make sure that that x times 2x plus 7 times 2x minus 7, right? If I multiply that all out, I'll get 4x cubed plus 49x. You can start wherever you want. You can distribute the x if you want, or you can multiply these. So x times 2x is 2x squared. X times 7 is 7x. So now I have 2x squared plus 7x times 2x minus 7. 2x squared times 2x becomes 4x cubed. 2x squared minus 7. 2 times 7 is 14. X squared, right? 7x times 2x is 14. X times x is x squared. Positive 7x minus 7 is negative 49 with one x. Good. These cancel, and I'm left with 4x cubed minus 49x. So if you're ever wondering what, if that fits, if you got the right answer, you can multiply it back out, see what you're left with, or you're also welcome to put this into Desmos. It will give you a graph, and then put your answer into Desmos and see if it covers the same line. Okay. Now we have 49 minus x squared. 49, oh, sorry. A is the square root of 49, which is 7. B is the square root of x squared, which is x, right? So that means we have 7 plus x times 7 minus x. All right, this one's weird, but if we don't overthink it and we just think, is this a perfect square? Is this a perfect square? Yes, it is, because the square root, A is the square root of all of this, x plus 1 squared. Remember, oh, I'm sorry. The square root cancels the second power. So a is x plus 1. B is the square root of 9, which is 3. So I have an a, I have a b. That means I just say a plus b times a minus b. If it works, it's allowed, right? That we followed the rule, we got that answer. You can also go back and check it if you want. Okay, this next, this is the last piece, right? And then 2 examples. All right, this one I would actually write down, okay? This one is we're dealing with cubes. So the cubes means that instead of 2s, you have 3s right here. So on your note card for this exam, I would write down the rule for the sum of 2 cubes means we're adding it, and the difference of 2 cubes means we're subtracting it. Oh, sorry. I would obviously need an equation for the difference. A cubed minus b cubed, so that's a mistake, is a minus b times a squared plus ab plus b squared. I apologize, bad. So sum means you're adding them. Difference means you're subtracting them. And cubes means you're taking it to the 3rd power. A cubed plus b cubed is a plus b times quantity a squared minus ab plus b squared. A cubed, this one's useless, I apologize. A cubed minus b cubed equals a minus b times the quantity a squared plus ab plus b squared. Okay. Again, we're just finding our a's and b's and plugging them into a formula. Okay. But the difference is cube. So we're not going to say what is the square root. A is not the square root of x cubed, right? A is the cubed root of x cubed, which means it has to be three times itself. That's what cubed means. Good. 1 has to be 1 times 1 times 1. So that really doesn't matter. Doesn't matter how many times you raise 1 to. 1 to the second is 1. 1 to the third is 1, right? You can keep going forever. But instead of looking for perfect squares, we're now looking for perfect cubes. And again, you can still use the internet for that. 1 cubed is 1. 2 cubed is 8. 3 cubed, I think, is 27. I'm not confident on my cubes. 4 is 81. 64. Good. So you can find a list of them or you can use your calculator, but we're only interested in these numbers now, not squares. So those are perfect squares. These are perfect cubes. Use this when you have a number cubed plus a number cubed or a number cubed minus a number cubed or term, okay? So in this case, a is the cubed root of x cubed, which is x. B is the cubed root of 1, which is 1. So this is a plus, so we're going to use this one. A cubed plus b cubed is a plus b times the quantity a squared minus a times b plus b squared. Now I just plug that in because I know a is x, b is 1. So we have x plus 1 times x squared minus 1 times x plus 1 squared. So I'm just taking, I found A, I found B, I'm plugging them in. x plus 1 times x squared minus x plus 1. Oh, I apologize. That's my answer. And you can go back and you can check it by FOILing. X times x squared is x cubed. X times a negative x is a negative x squared. X times 1 is x. 1 times x squared is x squared. 1 times negative x is a negative x. 1 times 1 is 1. Right? This cancels with this. This cancels with this. And I'm left with x cubed plus 1. So you can go back and check your answer. But what they're looking for is the factored form. So they're just looking for that. Last one, I think we can get it done in 10 minutes. What they're asking us to factor is y cubed minus 64, and then 64y cubed plus 1. Good. So A is the cubed root of y cubed. The cubed root of y cubed, that cancels that, and we just get y. B is the cubed root of 64. So you can take your calculator and put in the cubed root of 64, or you can just 3 cubed, or even 3 times 3 times 3, 4 times 4 times 4, right? 5 times 5 times 5, if you want to do it that way. So the square root of 64 is, or sorry, the cubed root of 64 is 4. So A is y, B is 4. What was that formula? That formula was A cubed plus B cubed is A plus B times A squared minus 2AB plus B squared. If it's negative, A cubed minus B cubed equals A minus B times A squared plus, ooh, sorry, that's from last time. AB plus B squared, I apologize. Ignore that too. Good. So this has a minus sign, so we're going to use A cubed minus B cubed equals A minus B times A squared plus AB plus B squared. Now we're just going to substitute in A and B. A we said was y, so now it's y minus 4 times y squared plus 4y plus 4 squared, right? Because A was y, B was 4. I just flipped it because it was easier. It's more natural for me to write it that way. Leave it as y squared, 4y, and then 4 squared is 16. So you are left with y minus 4 times the quantity y squared plus 4y plus 16. Good. All right. Here we have 64 y to the third plus 1. A is going to be the cubed root of 64y cubed. We know that the cubed root of 64 is 4. And the cubed root of y cubed is y from over here. The cubed root of 1 is just 1. And we're going to input it into this one. A cubed plus B cubed equals A plus B times A squared minus AB plus B squared. Just substitute those right in. A is 4y. B is 1. A squared is 4y squared minus 4y times 1 plus 1 squared. Good. Make sure you put the parentheses around that 4y because the 2 has to go to the 4 and the y. So that's 4y plus 1 times 16 y squared minus 4y plus 1. So I can take 4 and square it, and it's 16, but y squared, I just leave as y squared because I don't know what y is. Good. All right, we have a second, so I'm just going to do one more example. 64. What if it was 64y squared minus x cubed y squared? What would you do? Talking the whole time, now I ask you. What can you do here? You can factor out a y squared. Okay, the first thing you need to do is factor out a y squared, because 64 is a perfect cube and x cubed is a perfect cube, but y squared isn't a perfect cube, right? So if there's anything common to both of them, you can take it out. So now we have that y squared times 64 minus x cubed. So now we know what to do, right? We have the y squared outside. 64 minus x cubed means that a is the cubed root of 64, which is 4. And b is the cubed root of x cubed, which is x. Good. So now you have y squared times, and that was subtraction, right? So the formula for subtraction is a cubed minus b cubed equals a minus b times the quantity a squared plus ab plus b squared. Right? So we have a minus b, which is just 4 minus x. Then we have a squared. 4 squared is 16. A times b is just 4x. B squared is just x squared. So that would be the simplest factored form of 64y squared minus x cubed y squared. So if you see that on my math lab, that's how you answer it. I'll stop our recording now.